Today's show is sponsored by Lightstep Incident Response, built on the ServiceNow platform used by over 6,000 companies worldwide. Lightstep Incident Response allows you to scale your incident response team without adding to your monthly bill. With intelligent on-call scheduling and escalations, you get the full context of your service health. Lightstep Incident Response immediately pinpoints issues and uses machine learning to send group text, reducing your time to respond. And you can seamlessly orchestrate alert and incident triage with on-call scheduling across Slack, Teams, Zoom, desktop, and mobile. So get started today with a free 30-day trial of Lightstep Incident Response by visiting lightstep.com/cloudcast. That's lightstep.com/cloudcast. And get a free t-shirt after your first alert or incident.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Hope everybody is doing well. We are getting towards the latter part of August 2022, and things are starting to cool off a little bit, which is nice, and hope everybody's doing well. This is usually our Sunday show, Sunday Perspective show. I was kind of getting on a roll of doing Sunday Perspectives. This one, we're not going to do a Sunday Perspective, and it's partially because I have a topic, and I only felt like I got about partially through what I wanted to kind of talk about. I didn't want to give you sort of a half-baked show, if you will. So I'm going to push that topic until next Sunday. Today we have a really interesting show. A lot of times, companies will say, hey, would you be interested in learning about some topic? And, we get to go through a lot of different things. And there's times when sometimes people will say, hey, this new thing has come along. And, quite honestly, this is the topic we're going to talk about is sort of an interesting one. It's really about security and encryption and really the new paradigm of working with cloud providers and how do you trust them and can you trust them? Should you trust them? So we really kind of get into a bunch of those topics. But this is one of those ones in which while Aaron and I try and stay up with kind of the latest and greatest of what's going on, sometimes again we get pitched a topic that we kind of go, can you really do that? Because it kind of bends a paradigm that we really haven't, I feel like we haven't necessarily crossed very much in the past. So today's show is going to be kind of interesting. We're going to kind of dig into some stuff with our friends from MongoDB, and we're going to do that right after the break. Today's show is brought to you by Granulate, an Intel company, and their new offering, gMaestro. gMaestro allows you to reduce your Kubernetes costs by up to 60% with autonomous, continuous workload, and pod right-sizing. With gMaestro, you gain full visibility into your Kubernetes clusters and eliminate over-provisioning without compromising performance or affecting your competitive SLAs. gMaestro can be installed with a single line of code and provides visibility into inefficiencies within your Kubernetes clusters. Users can automatically apply HPA, CPU, and memory request changes that can be employed to save up to 60% on compute costs. And the best part, it's absolutely free. Try gMaestro yourself at granulate.io/gmaestro to begin optimizing your Kubernetes today. That's granulate.io/gmaestro to begin optimizing your Kubernetes today. Today's episode of the Cloudcast is sponsored by Datadog. Bring speed and scale to your security organization. Datadog Cloud Security Platform delivers real-time threat detection and continuous configuration audits across applications, hosts, containers, and cloud infrastructure. Built on top of the observability platform, Datadog brings unprecedented integration between security and DevOps aligned to shared organizational goals. As a listener to the Cloudcast, you can sign up for a free 2-week trial to see for yourself how Datadog can elevate your cloud infrastructure security posture by visiting datadog.com/security-cloudcast. Sign up now and receive a free Datadog t-shirt. That's datadog.com/security-cloudcast. And we're back, and Aaron, it's good. We're kind of on a streak here. A couple of shows with you and I back to back. It's good to be co-hosting again.
Yeah, absolutely. And it'll be interesting as we go into conference season and whether or not we actually have a conference season, how long this streak continues, but definitely good while it's lasting.
Yeah, absolutely. Today, we're going to dig into something that you and I are always sort of fascinated in, sort of everything in the security realm. But at the same time, you and I are very quick to point out that we're by no means experts. And today, I think is going to be very interesting because a lot of times we're seeing notifications, news stories about so and so company got hacked, and we're starting to see more and more postmortems that kind of detail how hackers got in, or where the problem came from. And today we're going to kind of dig into how do we better protect things on the inside, and especially how do we protect data and around those things. And so really excited today to be able to not only talk to somebody who really knows this stuff, but also a really new technology that's coming out around it. So really excited to have Ken White, security principal at MongoDB. Ken, welcome to the show. Great to have you on.
Thanks, Brian. I'm glad to join you all.
Let's sort of start before we dive into some of the exciting things that you guys are working on. You have a pretty interesting, distinguished career around security, around sort of cryptography adjacent types of things. Give us a little bit of background of the areas that you've been in the past and helped sort of drive and create, and then really where you're focused at these days at MongoDB.
Sure. First I should probably qualify this by saying this is a very unconventional path. I don't know if there is a sort of a true standard path to security, but mine's kind of weird. So formally my training's in computational modeling and neuroscience. And I spent many years doing work on imaging. So things like a functional MRI and PET scans and heart imaging and things like that. And kind of got into the math and got into the methods and the techniques and kind of the equipment more than the science. And at some point I realized, hey, I really like this, real-time embedded programming stuff. And so spent a few years doing that. Eventually got into kind of the operation world of clinical trials. And as you can imagine, when there's a new compound, new drug being developed, it's, often a really high stakes business with really sensitive security requirements around, patient data, things like that. And so worked for several years kind of in the network defense space and, security ops and, sort of defending, the systems from bad guys.
Yeah.
I sort of moved deeper into the network side and did some work with the Linux Foundation and the OpenSSL project for a while. We did a full kind of cryptography audit on that software, which is, as you and your audience may know, is kind of everywhere. It's on everyone's phone. It's in equipment and devices, gaming stations, banks run it. It's kind of everywhere.
Yeah.
And then I guess over the last several years, I've been kind of more focused on sort of applied usable crypto. And so I joined MongoDB around 5 years ago and was recruited to kind of build in end-to-end crypto for the database, the community database and the managed service we call Atlas. And so that's what I've been doing. And then had the pleasure in the last 2 years, I guess, working with a cryptography team who had developed some really innovative, cool tech that lets you do things like actual, expressive queries and searches in databases on completely encrypted data. So the idea is that, the database and the operators and the equipment and the, cloud providers, they're completely oblivious to the information the data is holding, the database is holding, but the end users or the applications can run, queries over it in a really kind of high performance way. So super excited to get into that. If you want to talk about that a bit or we can kind of go wherever you like on the applied crypto world.
And Ken, so I do want to kind of peel back the onion just a little bit on that, but also step back and also talk about a little bit of origin, if you will, right? So what we're seeing a lot of times is in the old days, maybe the more hacks were coming externally, but then I feel like, more and more things are happening internally at times as well. And so from a both security and cryptography perspective, where do things typically break down, and where did it then, make something like the database being fully encrypted and you're still able to query against it, make that maybe even a necessity going forward?
Yeah, one of the advantages of the of the work that I do in my position, because I've got a really quirky mandate. So like if you look at me on an org chart, I'm just sort of sitting out kind of by myself. But what's really interesting about the work I do is I have nearly complete autonomy. So on any given day, I may be speaking to like a group of, Python developers in Omaha. The next day, I may be speaking to a managing director at, one of the world's biggest investment banks on their sort of core currency platforms. Other days, I'm working with our engineering group on sort of iterating on, next versions of products or product design. And then, I also work with what we sort of refer to as strategic customers. So these are folks that, they're not just interested in, some bell or whistle that we're going to roll out next week. They're building, security technology into the core part of their entire business. And so it's a long-term partnership. If you adopt a technology for your operational data store, for example, that banks refer to, or for things like, currency exchanges or bank-to-bank settlement systems, those are long-term, embedded systems. And so, the kind of security concerns and things that are top of mind for folks like that are very different than maybe sometimes in the startup world, where people are just interested in kind of, the basics and just sort of just standard data assurance and sort of, privacy controls and things like that. And so I sort of see it from the perspective of how can I build some of these, sort of more useful security controls into my software without being a security expert or much less a cryptography expert. And just, how can we sort of lower that friction, make it easier for developers in whatever language and whatever framework, easier for them to use, but then also address some of these really niche, extremely sensitive workloads. So, for example, we have customers that run entire national pension systems. So, for example, there's a country in the UK where literally every infant, mom, dad, working adult, retired pensioner in the country, all their financial data, all their healthcare records, all some of the most sensitive information you can imagine is stored and protected with some of the technology that we built. So the concerns and kind of, perspective of organizations like that, very different than, I'm building some, really, rapidly innovating, social media platform or some, some other space and, trying to get first to market or kind of, really iterate. They're very different perspectives. So we have to kind of context switch quite a bit. And, and honestly, a lot of what the work we do is kind of, just education, because I know people that have been in the cloud computing world for years and still don't know, like there's a joke that if you're certified in Amazon or GCP, that means almost nothing in a year or two, right? Because there's so many new services and characteristics and, properties and things and techniques and such. And so, there's some real truth to that. So sort of always constantly kind of moving with, with the industry and trying to keep pace with, the updates and things that are out there.
Yeah, no, it's interesting that you mentioned that you're sort of like, well, I'm sort of off on an island on the org chart or whatever. Aaron and I have always joked, there's kind of two kinds of security people, especially at large companies. There's the ones that everybody's sort of afraid of because they're heads down doing their thing, and then there's the ones, it seems like you, who are can go and talk about this stuff in incredible depth and at the business level and the technology level, and you just sort of go, I don't really know what he's talking about, but we need to put him in front of our most important customers. So yeah, it makes a ton of sense. So recently, MongoDB, you sort of hinted at this at the beginning, but Mongo just recently, or is in the process of launching some technology that lets you do querying encrypted data, which we've always sort of been like, well, how do you do that? You have to unencrypt it. Like, talk to us about what this new system does, sort of the idea behind it, and sort of a little bit of the basics of how it works.
Yeah, no, absolutely. So, I mean, this is, I think cryptography in general is one of these things that is just, is really misunderstood a lot in the industry, and frankly, even by security professionals, people that have been doing this for a long time, and often even CISOs. Like, there's just a lot of misconceptions and sort of, people's mental model of how the world works I think sometimes is misled, partly by kind of Weasley marketing, to be honest, and then also just some of these concepts are kind of complicated or nuanced, and that's if you don't live in this world, it's easy to misunderstand. So for example, you do a quick survey today of, I don't know, half a dozen of the most popular cloud databases, and every one of them will say, we offer our databases are encrypted. We have encryption at rest, encryption, in transit. And, we have a lot of customers that sort of have this notion that, well, I'm using encryption at rest. And so because I have the keys, my data is safe. And it's like, well, encryption at rest is important. And, having keys that you can, that you manage are, that's an important control. But let's kind of drill into that. So for example, when you run on Amazon or GCP or Azure and you enable encryption at rest, whether it's Lambda or just a core compute instance or or some kind of app service, what you're really doing is two things. One is you're protecting against a scenario where someone comes into an Amazon or Google data center, and let's assume they get past the biometrics and the laser sensors and the dogs and the fences and the, and all the other physical controls, and actually gets into just the right server cage with just the right server where your data is running, pulls a hard drive, and then goes and steals it. Yes, that's one of the controls. A lot of those things were put in place for things like corporate data centers where, servers get retired all the time, and when one has, given up the ghost, it's done. It's 4 or 5 years in service. It's put in some, storage place or whatever. And then maybe eventually it ends up on Craigslist or eBay or something. And then you really do care, have you protected the data that are sitting on those disks? But that's not really a major threat like in modern times, right? The other thing that something like encryption at rest protects is things like, well, I've used this, virtual machine for a while. I've done some, project or, some analytics or something, and then I terminate it and it sort of goes back into the fleet, in the cloud provider's fleet. Well, we want to make sure that the next person that comes along, if they like look at the disk, if they run simple tools to just sort of read the raw data from the disk, that they're not seeing your data. So those are important things, but they have almost nothing to do with hackers, right? They have nothing to do with like active attacks that I think people think about. So a lot of it's sort of like education. Same with in transport, right? TLS, HTTPS, those things are important, but they're around eavesdropping. They're not really around like active hacks. And yes, of course, there's exploits and things you can do at that layer, but generally by having encryption at rest and encryption in motion, you've covered a few things, but you haven't really fundamentally addressed what about things like a service that's up and running? What about a thing like a database that's up and running? Encryption at rest doesn't help your database. It's active and running, right? I mean, I don't know about you all, but when I run a database, it's most useful when it's actually mounted and listening, for queries. And so when that's the case, the fact that if it's turned off, it's safe doesn't really help me. So anyway, a lot of sort of basic education on that. What people almost never talk about is encryption in use. While I've got my web service up or my app service, and I need to update some customer record or user record with a mobile phone number, a social security number, a credit card number, something like this. Where is it exposed? How can I protect it while it's being, actually used in the application? Now, obviously, you have to trust your application because that's what you built, and that's sort of the source of truth, and that's where the clear text comes in, right? That's, it's pulling data from the application. But once it's on the database or the web service or whatever, how's it being protected? And frankly, the answer in 99% of the world is, well, it's not. We just sort of, we have a, trust that, you've got the appropriate administrative controls and legal language in place for a contract that says, my provider won't snoop on my data, and they promise that their, staff or employees won't look at my things. But those are administrative controls. Those are like, Bob will get in trouble, or Bob will get fired, or Bob will go to jail if they do these things, which are good, things to have in place. But they don't have anything to do with whether Bob can read your data, or Amazon could see your data, or we as a service provider could either intentionally or maliciously, access something. It just doesn't address that one way or another. And so encryption in use is something that you need to think about if you're talking about really sensitive data. So I'll stop there if that makes sense.
No, it does. And Ken, thank you for that. But I'll actually even take it one step further and kind of from a more practical side, because it may help some of our folks kind of put the pieces together and connect all the dots here. If we break it down to a component level, you've basically, the way I pictured it is like, okay, you've got the database, you've got the application, you've got, keys and key management. Where does all of this fit together to make the complete puzzle or the complete picture? Like from a practical standpoint, how do all the pieces fit?
Yeah. So, I mean, if you're using a lot of popular open source databases and you're kind of self-managing, right? You spin up a virtual machine on one of the big cloud providers and you configure it, you set it up. There's a whole lot behind that to get you at a very minimal basic level of, sort of a good security posture. You got to create TLS certificates, right? So that your app is talking to the database over an encrypted channel. You've got to make sure your operating systems are updated and patched and keep getting updated and patched. You've got to make sure that if you are doing things with keys that you're limiting the access to those, that you're not spilling secrets into your source code that may end up in code repo like on GitHub or something. You have to make sure that you've sort of thought through really carefully how you want to do authentication, right? Do you want to do some traditional thing with a username and password, and then you deal with password, storage techniques? Do you want to use federated identity? And then, if your application is doing anything at all that's sensitive, how are you monitoring it? Do you have alerts? Do you have audits? Do you have these things? And obviously, if you're if for a lot of applications, it's just the bar is not that high, right? You're just you want to do the basics. You want to make sure you're not getting DDoS'd and and you've got some basic things in place for decent credentials and the way that you do administration. But other times, you like as you said, you kind of want to think about the whole package. So one of the things that we really focus on, and frankly, I think it's one of the reasons that, from a company perspective, the managed service, the Atlas platform has really taken off, because people don't like that. They don't like to deal with sharding. They don't like to deal with backups. They don't like to deal with, OS patches or taking systems down. I mean, I'm not trying to be salesy, but it really is useful for any service that can say, look, we'll make an exchange. We have certain responsibilities and we're willing to do the backups and the patching and make sure that when we do those things, your database doesn't stop. It doesn't have to come offline. We can do those things in a high availability way. Like, in our case, even if you're just like, you spin up like a developer instance and it's just like a toy kind of sandbox, playing around kind of thing. Even in that scenario, you're going to get encryption at rest. You're going to purpose, generated volume encryption key. You're going to get TLS. You're going to get strong auth. You're going to get network, filters. You're going to get, auditing that all you have to do is ask. All you got to do is either consume the API or pull logs back. You're going to sort of get all those things for free. And so then you can really focus on the app. And that's really powerful. I think there's sometimes when people do the, economic calculation, it's like, well, if I buy X number of hard drives and X, servers, it's so much cheaper if I do that than this. And it's like, well, right, but you haven't really taken into account the opportunity costs, the army of DBAs and sysadmins and things like that, which maybe it's not a big deal if you're talking about a couple of virtual machines. But when you start to scale up, then these kind of things really matter. So to the extent you can let developers focus on building the app, doing what they do in Python or Java or C# or Go or whatever, and making it easy to get up and going. And by the way, having as much sort of free security, if you will, that's obviously the best case. I mean, one of the things that we discovered over the last several years in building end-to-end encryption in the database for customers who have, really sensitive records is we didn't spend a lot of time on the crypto, frankly. We thought we were going to spend, 70, 80% of our engineering effort on, the crypto piece. It's not. It was all around queries. It was all around, drivers and documentations and tutorials and things like that just make it easy so that you don't have to think about some of the, kind of lower level mechanics. I think that was really surprising. But in our view, as much as you can make security easy and usable and kind of just something you flip a few configuration switches, that's a huge win. And I don't just mean for business, that's a huge win for anyone, right? The easier you can make it for developers to get to a kind of a decent place in terms of a security posture, that's obviously the ideal.
Yeah, no, that's very, very cool. And for folks that are listening and they're going, okay, this stuff is hard to sometimes communicate through an audio medium. We've got a bunch of links in the show notes, as we always do, but a bunch of good things, both talks from Ken as well as kind of diving into this in more depth. So don't swerve off the road hoping you had a whiteboard. We'll get you covered there. Ken, what are some of the application use cases for this? I mean, is this something that you expect to see people going, I'd like to have this enabled for all my applications that use Mongo as the backend for them? Or is there sort of special use cases where this makes more sense, maybe due to, there's maybe a performance hit or something? Like how are you guys thinking about it? How do customers think about where this makes the most sense for them?
Yeah, that's a great question. I mean, the initial sort of heavy push came from the financial services sector and from healthcare, right? So we have, some of our customers are huge North American insurance companies, health insurance companies that are sitting on, massive amounts of patient records and prescription data and things like that. And it's just tough to make a cloud migration story without deeply thinking about how you're going to protect that kind of information. Because, in the banking world, particularly in Europe, there are tranches, right? There are tiered multipliers, so that if you have a breach and it affects, X thousand customers versus 100,000 versus, the higher the number goes, it's like an existential threat to the business kind of thing, right? If you have a breach over a certain level, it's literally a matter of potentially, facing the closure of business in regions, right? I mean, so these are really serious, kind of stakes that we're talking about. So things like safely storing credit cards, things like safely storing medical records, PII, things of this sort. That's what kind of started it. But I'll say that, within a few weeks of the launch of the Queryable encryption that we announced in June, and actually, I guess a few weeks before that, we had 60, 70 customers that were signing up to do evaluations. And it's one thing to say, like, a CISO is sort of saying, well, we kind of want to learn a little bit more about this or kick the tires. It's another when you're getting like whiteboard sessions where people are like, okay, well, exactly how does this Java parameter work in the Swing framework when you're doing, subdocument, when you're storing contact or, customer information files like this, or, how do you use this in Go on, in a Kubernetes context, or how do you use this, C#.net with your encryption, but on like Linux, like really getting into the mechanics of, specific implementation details. That's when, people are serious. And so to that end, I mean, I can't show you the, our list of customers, but I mean, it's things like the obvious, big banks, investment banks, retail banks. It's also currency platforms. It's bank-to-bank settlement systems. It's tech companies. It's these big gaming franchises. Like I'm not a big gamer, but you all may know this already. But there are individual titles that are multi-billion-dollar businesses with a whole kind of ecosystem of economics behind that around the gaming thing. And so, gaming is a big area. We have pizza chains, right? We have, anybody that's dealing with credit cards or credit transactions or point of sale systems or payment systems, there's potential interest too. So, retail pharmacies. I mean, it's really just all over the board. We're seeing interest in nearly every vertical. But fundamentally, it comes back to, I'm a developer. I have requirements that says I need to treat this, these data in a really, in a really privileged way. Really have to do every, reasonable thing we can do to assure confidentiality. We're also seeing it for people that are interested in mitigation for ransomware, right? I mean, because there's two elements of ransomware. One is that you're locked out of your data, but the other thing that's frankly a higher risk to a lot of people who talk to us are, well, what happens if we have a ransomware attack and the proposition is, well, pay us, X million dollars in Bitcoin, or we're going to dump your data. And so if it's encrypted on the database and somehow there's some kind of application compromise or something, you can destroy my data, but you're not going to dump it anywhere. We're not leaking it, right? So there's all kinds of interesting kind of perspectives and use cases of these things that we've seen already.
Yeah. So Ken, that you bring up the really fascinating point with that last bit, and also too, I'll just kind of add, the ransomware / malware aspect of all of this is definitely one of the big hot topics. But if folks wanted to dig deeper into this and they wanted to really kind of start exploring some of this tech, just to kind of recap, is it just software? Is it SaaS? What's the best way you would recommend for somebody to go as a next step?
Well, I mean, specific to Mongo, so we've implemented it in all of our products. So if you're using the open source community edition of Mongo, just Google Queryable encryption. I think we're one of the first or second hits straight to our docs, and those are pretty straightforward. Like, pick your language, pick your operating system, get the driver, install your, whatever Java framework or Node.js framework or whatever. And here's a very simple kind of copy pastable hello world, and so we have like tutorials and things on, with I guess a dummy healthcare record or things like that. We've also just got literally kind of hello worlds where your whole point is, 20 or 30 lines of code to get you from sort of ground base to I've created some keys. I'm going to insert an encrypted record. Now I'm going to retrieve it. But yeah, it's all through the software. We're big believers in transparency, and so one of the things you can imagine is really important in the crypto community is there's like a really strong pushback towards any kind of proprietary or black box, cryptography. So we've open sourced the core crypto framework. It's Apache license. It's all out on GitHub. Most developers would never have to touch GitHub. They just download the database and the drivers the way they normally would. But we also offer it on the Atlas platform, which is our big managed service. And so just by way of kind of context, I mean, Atlas is, we manage over 2 million plus databases around the world right now for customers. And so these are, we're running in 200 different data centers on every major cloud provider. So it's a massive operation. And so if you want to use this system on Atlas, you can do that. If you just want to use it standalone, not even connect to the internet on a developer laptop, you can do that as well. It integrates with all the native cloud key providers. So Amazon's, KMS, Google's Cloud KMS, Azure Vault. If you're into HashiCorp, you can use HashiCorp Vault. If you've got like really strict institutional requirements that require things like a hardware security module, we see this a lot sometimes in the banking space. It interoperates well with that, and it's completely portable. So you can move it from, say, an ARM system on Android to x86 running CentOS or Amazon Linux or something like that, and so the data are portable across it. We're also big into like not locked, anti kind of vendor lock-in. So if you want to, if you spin up some system in a QA or dev environment and you're managing the keys with something on Amazon, but you want to migrate to GCP, you can do that with a single API call, which is kind of cool. If you wanted to move from like a developer instance where you just got like a local key and you want to move, the keys that are protecting your data to, say, an HSM, you can do that as well. So, but yeah, the docs are out there. The tutorials, the copy paste stuff is there. And then obviously, folks can always reach out to me and my team. We're happy to talk to developers, one-on-one, or, we talk at conferences and things all the time. So whatever's the easiest, we're happy to work with people.
Yeah, good stuff. Good stuff. Well, Ken, listen, you are a busy man. We want to be respectful of your time, but thank you so much for not only introducing us a little more to this space, but really kind of diving into it and giving us a good, kind of a good starting point for wanting to learn more stuff. As I mentioned earlier, folks, things like Ken's Twitter will be in the show notes, as well as, a bunch of pointers to really good FAQs and docs and conference talks that kind of start to dive into this. So,
I should caveat that, by the way, saying that if you're welcome to follow me on Twitter, but I'm probably as likely to talk about dogs or curry or things like that than crypto. But I'm happy to talk to all takers.
Yeah. Now, well, we're all multifaceted individuals, so people can comb through what they like. Well, good stuff. Ken, thank you again on behalf of Aaron and I. We really, really appreciate it. Folks, we're going to wrap up there. Again, good to have Aaron back on the show and two of us doing it together. Thanks everybody for listening. We're coming out of the summer, the dog days of summer. We're going to get into a lot of interesting things as trade show season kicks off. But thanks for listening. Thanks for telling a friend. Thanks for helping us grow the community. And we will talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.